Hello friends, today we are going to talk about the FM radio receiver.
In the electromagnetic spectrum, the bandwidth of FM signal is from 88 to 108 MHz. FM stands for frequency modulation and it is used in radio broadcasts. Here, frequency modulation refers to varying of radio wave frequency to carry audio signals over long distances. Hence, the devices which are able to receive such signals are called FM radio receivers. Let us look at the block diagram of a FM radio receiver. The antenna receives the transmitted radio waves which flow through the metal antenna, making electrons vibrate inside it. This produces an alternating current, recreating the original signal. This signal, however, has unwanted frequencies as well as image frequency, which results in two stations being received at the same time, producing interference. Hence, this signal is passed through the RF filter, which blocks out the unwanted frequencies using a band pass filter, giving the desired frequency. This signal is amplified by the RF amplifier and passed to the mixer. Here, the signal is mixed with another signal produced by the local oscillator. The output signals have frequencies as the sum and difference of the two input frequencies, which were mixed. The output signal from the mixer is then passed through the IF filter, which filters the input giving the desired frequency. This signal is then amplified by the IF amplifier and passed to the demodulator. The demodulator uses a limiter to remove the noise peaks and amplitude changes before detection of the FM signal. It then recovers the original audio input wave from the modulated wave using a discriminator by separating the input wave which was modulated on the carrier wave. Part of the signal is then fed back to the local oscillator as an automatic frequency control voltage. The signal is then amplified by the audio amplifier and then fed into the speaker, which provides us with the final sound. Let us look at the working of the receiver circuit.
The circuit consists of a regenerative AF stage transistor TR1 to detect the frequency modulated signals, coil L1 and the variable capacitors VC1 and VC2 forms the tune tank circuit as known as the LC oscillator to tune the receiver to the FM station with strong signals. The drain resonator inductance is center tapped with feedback to the source through a small capacitance. The signals are capacitor coupled through C3. This is followed by 2 up 3 stages audio amplifier TR2 to TR4. The output is received through the headphones after the signals pass through the band pass filter circuit. This kind of receiver is called super heterodyne receiver, which uses the frequency mixing to convert the received signal to a fixed intermediate frequency, which can be more conveniently processed than the original carrier frequency. The resonant frequency of an oscillator circuit is calculated by the formula omega equals to 2 pi f equals to root under 1 upon LC, where L is the inductance of inductor and C is the capacitance of capacitor. This implies that the resonant frequency is dependent on the capacitance of the variable capacitor. By turning the knob of the radio, we actually change the capacitance of the variable capacitor, which in turn changes the resonant frequency. Since the frequency of filter equals to frequency of input signal minus frequency of LC oscillator, where the frequency of filter is fixed. By changing the LO, F gets changed accordingly and this frequency passes through the filter to get demodulated. So let's say we wanna tune into 93.5 Red FM. The frequency of LC oscillator must be adjusted such that frequency of input signal is equal to 93.5 MHz.